Now this worksheet is the second one I handed out at the end of class. This is the one that's entitled Proofs Using the Reflexive Property in Vertical Angles. So, in this case, for number 1, we're given that angle B is congruent to angle L, and angle BAE is congruent to angle LAE. And then we also know by the reflexive property that angle AE is congruent to itself. So this one's pretty simple. We're just going to write what we're given. So angle B is congruent to angle L. Angle BAE is congruent to angle LAE. And then we know AE is congruent to itself by the reflexive property. So now we look at our triangle, and we have an angle, angle, side. So we know that triangle BAE is congruent to triangle LAE by angle, angle, side. And we'll go down to number 2. For number 2, we're given that angle SUY is congruent to angle NUY, and that angle SYU is congruent to angle NYU. And again, by the reflexive property, we know that UI is congruent to itself. So just like with number 1, we'll start out with what we're given. Alright, so then we had that segment UI is congruent to itself by the reflexive property. Then we know that triangle SUY is congruent to triangle NUY. We come back to our triangle and we have an angle, side, and angle, and that side is included, so we know we have ASA. Looking at number 3. It's given that segment NU is congruent to segment MU, and that angle E is congruent to angle B. So we have a side and we have an angle, so we need another piece of information, and we can see here that we have vertical angles. And they are congruent. So we'll start with what we're given. Segment NU is congruent to segment MU. It's a given. Angle E is congruent to angle B. That's a given. And then we said that angle NUE is congruent to angle MUB. And now remember, that's not from the vertical angle. Like, that's a definition, is just angles that are non-adjacent. But it's from the vertical angle theorem that we know that they are congruent. So the vertical angles theorem, so then that tells us that triangle NUE is congruent to triangle MUB. And we have an angle, and a non-included side. So that is by AAS. You can flip it to the back and we'll look at number 4. Number 4, we're given that angle 1 is congruent to angle 2. Now this one's a little different because it's already got 1, 2, 3, and 4 written in. So just like we would with our letters, we'll make our curves for angle 1 and angle 2. And then we're given that segment AB is congruent to segment CD. So AB is congruent to CD. So we have an angle and we have a side. And then we have this line down the middle that's congruent to itself by the reflexive property. So we'll start with what we're given. Then we said that segment BD is congruent to itself. Oops, segment there. And that's by the reflexive property. Then we know that triangle ABD is congruent to triangle CDB. When we look at what we have a side, an angle, and a side, and that angle is included. So it's congruent by side, angle, side. Looking at number 5, we're given that angle CAN is congruent to angle IAN. So we have CAN congruent to IAN, and that segment CA is congruent to segment IA. So we have a side and we have an angle, and then we have this side down the middle, which is congruent to itself by the reflexive property. So we'll start out with our givens. And then we said that segment AN was congruent to itself. And then that tells us that triangle CAN is congruent to triangle IAN. And so what we have a side, an angle, and a side, and that angle is included. So it's congruent by SAS, side, angle, side. And then we'll look at number 6. We're given that angle R is congruent to angle Z. Segment CA is congruent to segment YA. We want to see that the triangles are congruent. So we have an angle and we have a side, and then we also have vertical angles here. We can start out with what we're given. Angle R congruent to angle Z. Segment CA congruent to segment YA. And then we added that we have vertical angles, so angle CAR is congruent to angle ZAY, and that is by the vertical angle theorem. So if we look at what we have an angle, and a side, and that side is not included. So we can say triangle CRA is congruent to triangle YZA by angle, angle, side.